There are trillions of planets in the universe, but even with our most powerful telescopes, we've never found a single trace of life out there. And no alien civilizations ever found us. It could be we're just not advanced enough to be noticed, or we're looking for the wrong things. So it's time to upgrade, make some interstellar noise, build some megastructures and megascopes, and find out whether we're actually alone in the universe. Today, we're going to speed up Earth's evolution and become an intergalactic Type 3 civilization on the Kardashev scale. That is, if we don't go extinct first. Of course, to become a Type 3 civilization, well, we'll need to reach Type 1 status first, because currently we are... that's right, 0.73. Scientists ran advanced machine learning computations a couple years ago, and the math said that's where we are on the Kardashev scale, which doesn't sound very impressive. Now, if you're wondering, what the heck is a Kardashev, and what's their scale, and what does it have to do with civilization? Well, that's completely fair, so let's back it up. The Kardashev at the heart of the Kardashev scale is Nikolai Kardashev. He was an astrophysicist and scientist, part of a team looking for extraterrestrial signals in the 1960s. In 1964, he wrote a short, elegant paper, Transmission of Information by Extraterrestrial Civilizations. It proposed that signs of life strong enough to cut through the universe's noise required civilizations that controlled and used staggering amounts of power to generate that much information, typically going out into the universe as radio signals. So Kardashev classified them into three straightforward levels of civilization, starting with... Kardashev described the Type 1 civilization as a civilization that controlled and used all the energy resources of its entire planet. In our case, that would be harnessing and using all the energy on Earth, so solar, wind, geothermal, fossil fuels, tidal energy, nuclear energy, fidget spinners, all of it. A Type 1 civilization would have full control over its domain. Control over weather, over the power of tectonic plates, volcanoes, earthquakes. Clearly, this requires technology that's far beyond where we are currently. So, we're moving slowly toward Type 1. Very slowly. Recent studies predict that we'll barely reach 3/4 of Type 1 by the year 2060, and it could take another 300 years after that, or more, to actually reach a full Type 1 civilization status. Which means, yeah, you're gonna have to put up with bad weather for a while. Now, if you're thinking, hey, I'd like to be around when we get better weather, how can we speed this thing up? Well, good question. Harnessing and utilizing that much energy is gonna require capturing all the solar power striking Earth and figuring out nuclear fusion, or digging up and burning every bit of fossil fuel that exists, which would have its own catastrophic effect on the weather. Okay, as everyone reaches for the phones to ask their favorite bot how we speed this up, yeah, the one glaring answer is artificial intelligence. And it's already in motion. Scientists at the UK Atomic Energy Authority are already bringing AI supercomputers online to help accelerate nuclear fusion research. DeepMind Learning recently revealed the structure of millions of new inorganic crystals that could be used for all kinds of technology, creating work that researchers estimated was the equivalent of 800 years of knowledge. So, great, maybe AI can help us get there fast. If it does, and we're able to harness all that energy, what would it be like on a Type 1 civilization? Well, we'd have cracked fusion, so we'd have what comparatively feels like infinite energy. We'd have control over our environment and the weather, so it would be temperate. It'd likely be more of a global community rather than a nation-state-centric planet, as we wouldn't be competing for oil in the same way. And ideally, we'd all have a basic universal quality of life, as we'd all have the energy to feed everyone, provide clean water and tech for everyone, and turn deserts into greenhouses. We'd have excellent travel, technology, medicine, materials, and we'd be starting to set up outposts in the solar system. Our AI-assisted civilization would be making some noise. Sounds idyllic and kind of straightforward, right? The Industrial Revolution took a few hundred years to get us to this point, so if it's only going to take a few hundred more AI-assisted years to become a stellar superpower, raises another question. Why haven't we found any evidence of any other Type 1 civilizations in the entire universe? Or, in the words of the great physicist Enrico Fermi, who over lunch with his fellow scientists muttered the famous line, "Where is everybody?" In short, the Fermi paradox is the idea that if there are trillions of galaxies, each with billions of stars, there could potentially be billions of civilizations out there. So why haven't we spotted one? And even if our instruments aren't precise enough to spot them, then why haven't we heard from a Kardashev Type 1 civilization? Or a Type 2? Or a Type 3? That's the idea Enrico Fermi threw out to his colleagues over club sandwiches in 1950, and we've been chewing on it ever since. The Drake equation, formulated in 1961, tried to quantify Fermi's paradox by estimating the vast number of stars and planets and comparing them against the fraction of planets where life could have evolved, as well as calculating how long those civilizations survived after reaching high-tech capacity. And the math says we should see another civilization, or millions of them, because there are so many planets out there. Just in our galaxy, estimates range from 1 or 200 billion to 1 trillion planets or more. That said, we've only discovered about 6,000 exoplanets to date. That's it. So there's still lots of room to search, but you'd think we'd have seen one sign by now. One megastructure, one anything. So if there's no sign of any other civilization, maybe there's a reason for it. And that reason is, maybe the reason we haven't spotted any other civilizations out in the cosmos is that they just don't exist. Maybe there's exactly one civilization that's achieved the ability to broadcast. Us, doing what you and I are involved in right now. Maybe that's it. But if that's the case, with the trillions of planets out there must be some sort of great filter that stops civilizations from reaching Type 1 sophistication. That's the idea that Robin Hanson floated in the late 1990s, where he laid out a number of hard steps that could potentially prevent intelligent civilizations from arising. It could be that some of these steps are nearly impossible. From the chemistry necessary to create life, to the Goldilocks nature of the planet needed to incubate it, to the leap from single-celled organisms to viable multi-celled life, and, figuring out how to do electronics. These steps took about 4 billion years on our planet, so we know it wasn't a quick, easy process. It could be that we're actually past the Great Filter, that we're one of the first civilizations to go from basic amino acids to functioning, broadcasting, energy-harnessing communities. Or it could be the Great Filter is still ahead of us, that civilizations reach a point where they can broadcast, even create interstellar probes with golden records, but they eventually, inevitably, destroy themselves. I mean, we came awfully close during the Cold War, where one rogue officer or faulty communication could have started the Third World War. We could have unloaded 70,000 nukes on our own planet. That would have kept us from reaching Kardashev Type 1, because, mutually assured destruction. And hey, we still have like 12,000 nuclear weapons kicking around, so we still really have to be careful about it. The fossil-fueled climate change is another long-term threat to our survival. The other option for the Great Filter? Artificial intelligence. We're all thinking about it. With the rise of LLMs and autonomous AI agents, looming artificial general intelligence, there are tremendous possibilities for accelerating humanity toward a Type 1, 2, or 3 civilization. But there's also the possibility that civilizations across the universe create what's called misaligned artificial intelligence, and it wipes out the civilizations that created it. We all tend to invoke Terminators or Judgment Day, and hey, there are autonomous AI drones in combat these days, so it is a working possibility. It's also possible that a rogue bot that doesn't understand the consequences of its actions creates a biological pathogen that kills every creature on the planet. An AI-created super pandemic. Or a bad actor uses AI without safeguards to create a chemical that devastates our ecosystem, or shuts down our power grids, or we become so dependent on AI that we can't do anything without it. Can't raise our kids or raise our crops, and when adversity hits, we've lost our ability to do even the most basic human tasks. The great silence out there might be evidence that most civilizations don't navigate this transition to the supercomputer artificial intelligence era and survive. Is it possible that artificial intelligences always destroy their founding civilizations? Is a universal law, like thermodynamics? Well, it's possible. So maybe we should be thinking, what do we want to do differently? What if we're at a bottleneck where our choices really matter? The way we work with AI, the constraints, the oversight, the laws around AI usage and development, they could all be critical to whether a civilization, let's face it, our civilization, makes it to 0.75 on the Kardashev scale, let alone Type 1. What if a civilization's foresight regarding AI capabilities is what determines whether or not it makes it to the next Kardashev level? Remember that open letter a couple years back that all the computer scientists and godfathers of AI signed, asking for a 6-month pause on AI training? With people as diverse as Jeffrey Hinton, Elon Musk saying it was time for sober second thought? Maybe it's that kind of community-minded thinking, of societal resilience, which makes better choices in regulating the types of AI that are built. Maybe that's what allows a civilization to survive. Or, as some scientists have noted, it would be safer to focus on building narrower, tool-like AIs, instead of building wide-functioning, agentic AI that can do almost anything. Maybe specific types of AI with built-in guardrails and guidelines can help us become incredibly productive and reach Type 1 without wiping ourselves out. That's possible. If so, and if we can avoid an AI-driven Great Filter, then maybe it helps us reach. Now, if our civilization is careful and thoughtful enough to overcome the Great Filter of AI, humanity would eventually progress to a Type 2 civilization. To reach Type 2, the decisions we make this decade will have a butterfly effect that will impact untold future generations of humanity. Because AI isn't slowing down, it's accelerating. In just the last 6 months, we've seen a 50% increase in AI usage per day. Personally, I want to see what comes out of a Type 2 civilization. Kardashev described it as a civilization capable of harnessing the energy radiated by its own star. So we'd have the full power of the sun at our disposal. How much energy is that? Well, Take every power plant, every solar panel, every ounce of energy we produce on Earth in a day, and you wouldn't even be close to matching the sun. Now, collect that energy for an entire year, and then do that again for another 639,000 more years? Well, then, and only then, would you match the total energy that the sun kicks out every single second. Yeah, Type 2 civilizations are pretty hungry. It would require a lot of building to get to that point. We're talking about creating mega constructs around the sun, designed to capture its phenomenal power. Just the amount of raw material it would take. We might be talking about strip mining Mercury or Mars down to the core to build Dyson spheres or Dyson swarms. If you're a science junkie like most of us, well, you've probably heard of a Dyson sphere. It's not a new kind of vacuum. It's basically a theoretical metal ball that civilizations would build around their star to capture all the starlight. Freeman Dyson cooked up the idea in 1960, saying, within a few thousand years of industrial development, any intelligent species should be found occupying an artificial biosphere which completely surrounds its parent star. The idea has led to all kinds of sci-fi novels, movies, along with deep research on the actual engineering. Maybe a Dyson sphere isn't possible to start, but maybe a Dyson swarm could be. Imagine millions or billions of satellites in orbit around the sun, capturing and focusing its power. Or we might be able to build a stellar engine, a massive sphere or disk that captures the energy of the sun and uses it to move the entire solar system. Or gargantuan, phenomenally powered laser arrays that could be used to move asteroids or trans-Neptunian objects around the solar system for raw materials. Need some water? Well, zap that incoming comet. It all sounds crazy, but these things were pure science fiction 60 years ago when they were props in the original Star Trek. I'm just saying, speculative science matters because here we are, able to communicate worldwide with the flick of a button. Does that make William Shatner the father of modern telecommunications? Now, these Dyson swarms and stellar engines aren't going to happen overnight. Even with cooperative AI, it's going to take at least a couple of thousand years. And by that point, humans and our AI agents could be melding. Yeah, well, if we're going to survive in space, we'll have to be genetically modified, and quite possibly directly interfacing with technology as we strive to reach a Type 3 civilization is a theoretical civilization that's in possession of energy on the scale of its own galaxy. So, for us to reach Type 3, we'd have to harness the power of all 100 billion stars in the entire Milky Way and the black hole at the center of it, Sagittarius A star, using theoretical constructs like a magnetic harness or some system yet to be discovered to capture the energy found in the black hole's accretion disk. Massive Dyson swarms and stellar engines would have the ability to push stars closer together to better capture and utilize their energy. They'd be controlled by other theoretical structures. Supercomputers like Matryoshka brains, giant computers the size of a solar system, powered by trillions of humans who've uploaded their minds to the computers. That's mega structures. Omega structures. I just made that up. But if you want to lump me in with Kardashev and Dyson, that's fine. We could build megascopes to look for other civilizations across the universe, which would help put Fermi's worries to rest and find out whether humanity really is the first species to get past the Great Filter. Now, even with the help of benevolent AI, this stage would take hundreds of thousands or millions of years, and we'd still be constrained by the speed of light. Even if we built tech that can achieve near light speed, the Milky Way is a minimum of 100,000 light years across, so it'd take a long time just to stretch our presence throughout the stars. It's possible we could use von Neumann probes to spread across the galaxy. Von Neumann probes are small probes designed and built to travel afar, settle down on a distant moon or planet, and set up a self-replicating system. They'd use the raw materials of the new planet to build more probes and send them shooting off toward the next system. Once a civilization has reached Type 2 or Type 3, covering an entire galaxy with its footprint, it doesn't take that long in the cosmic scale of things, which is why it's weird that we haven't seen anyone else do it. Soon, humans would have their representatives hurtling across the entire galaxy and heading into the next, Andromeda. It's only a couple 100 million light years away. Now, you notice I said representatives. Look, if Earth becomes a Type 3 civilization, maybe the first Type 3 civilization, it's hard to conceive how it does this with humans and machines as we know them today. We'd likely be a mix of human and machine, some sort of deeply interconnected galactic internet super beings out there creating that massive radio signal. And whatever we could think of, we'd probably be able to do it through a hybrid of artificial and natural intelligence. But getting there means learning to work with artificial intelligence to avoid any possible great filter threats that it might present. And maybe together we can solve the greatest future threats that humans and artificial humans could face, like our sun becoming a red giant in 5 billion years. But that's a story for another What If.